welcome once again, everybody. Thanks for spending time with us today. I will be talking about the improvements for the architecture and the structural engineering platforms. My colleague Matt Stacconi will have a separate webinar for the mechanical platform. So let's get started. So the first enhancement I'd like to speak about is the depth queuing. I'm sure a lot of you have already heard about it because there's quite a bit of buzz generated around this particular tool. It lets you add depth to your elevations and sections and create stunning visuals. And it's been in the works for a very long time. It's been on the wish list for a very long time, and it's finally here. So this functionality works with shadows on, realistic, hidden lines, sketchy lines, ambient shadows, anti-aliasing, and more. It practically works on any view effect, and you can turn it on, and you can specify where the depth starts, stops, and also the limit. So just as a small example, if I have, this would work primarily on elevations and sections. So if I were to go to this particular elevation, the control is available in the graphic display options of the view. And here you see, when my mouse is, you'd see that you have an option to turn on the depth queuing. So as it stands right now, you don't see much. Okay, and 0 stands for the point where the elevation of the section cut plane exists, and the 100 is 100% to where you can fade. So if I move this 100 further in and say, start fading at 52%, I end up with something like this. Now I also have the near option, so I can change the near. So whatever is in the 0 to 16% range will show with the full the default object styles, and everything else beyond that shows up with the fading, with the depth perception. You also have something called the fade limit that lets you change the intensity of the fading. So if you find that the default is too light, you can change the intensity by using this slider. Now typically, I'm sure all of you know that you would use this in conjunction with the silhouette tool, so that you can actually have a little bit more emphasis on the outlines of walls, window openings, roofs, and so on. So this particular tool is primarily geared towards anybody who, architects, but anybody who wants to really make use or show depth in their elevations and maybe gradations in their buildings and so on and so forth. Really good enhancement for this year. Next, we have a modification or a change in functionality for railing hosts. The fundamental change here is that you can attach railings to pretty much any profiles or wall profile or floor shape. So let's say, for instance, I had a rectangular floor like so, and let's say I used the shape edit tools to change the geometry of the floor, albeit a little extreme in this case, but I've changed the geometry of the floor nevertheless. I can use the railing tool now and say I want this floor to be my host, and then I could go and drop this railing onto this floor like so, all the way around if I want, and when I'm done, you'd see that the railing follows the profile of the floor. So you do not have to jump through hoops or resort to adaptive components or do anything else, any other workaround to achieve the same effect with the 2017 version. Next, we have something called the format 360 converter. If you have access to the raise hand button on your webinar, your GoToMeeting panel, I'd like you to raise your hands if you have heard of Format 360 in the first place. Okay. All right. So about 15% of the audience has raised their hands. So that's a good sign. But for those of you who haven't heard about Format, this is basically an easy-to-use SketchUp-like environment where you can do something as mundane as massing studies and bring in your Google Earth imagery. You can specify where the location is and so on and so forth. You can do pretty much whatever your massing tool can do, including setting up floor plates. But in addition to that, you can also do energy analysis using the DOE 2.2 simulation. And now Autodesk has added a few more features to it. So it's an easy-to-use tool. It has a few integrations. It has a fantastic integration to Dynamo Studio that lets you bring in Dynamo graphs generated geometry into this environment. So this functionality has been integrated into the Revit 2017 product, wherein you can generate a form or mass or whatever you need in this environment, and then you can just go into Revit, and in the Add-ins tab now, you have the Convert RFA to Format 360 app add-in. You can also import Format 360 to Revit. So I can just bring in that building over here. Format sometimes works one version earlier, so you have the access to that mass right here, and this mass is an RFA mass file. Now Format has a few more functions that's tightly knit with the Dynamo interface. So I can, for instance, sign into the Dynamo, where do we have that? So I can sign into the Dynamo website here, and I can, these are, what you see down here below are Dynamo graph generated geometry. So essentially you set up a geometry in Dynamo, and then you can change its parameters. You can enter text values, and it takes a while to update because this whole thing still lives in the cloud. But I can simply take this geometry, take this URL from here, and then bring it in to Format by just pasting that URL over here. And what that does is it allows you to bring in the geometry. It does take some time. It needs a second there. Hopefully not too long. If not, I'll have to abandon this. Okay, so it's here. So it brings in the geometry that you have generated through the Dynamo interface, and then you can start to change parameters of the geometry like so. So a fascinating little tool. It's fairly new, so we're still playing around and figuring out how we can use this efficiently in our projects. Later on, I have a little demo with Dynamo where you're not dealing with funky geometry anymore, but you can use Dynamo for very practical purposes. So we'll speak about that when we get to it. All right. So the next item on the agenda is something known as Insight 360. Now this is something that's included in your subscription, in your Revit subscription, and it gives you a fast and intuitive outcomes-driven guide to a better building energy and environmental performance throughout the building cycle. So by simply applying a geographical location and utilizing Revit's automatic energy analytical model, you can get some clear guidance and recommendations that's powered by simulation engines. Okay. Now, in addition to the DOE 2.2, you also have access through the simulation engine to the energy cost range factors, and it integrates many of the workflows such as Revit energy analysis and lighting analysis, as well as expanding these tools to provide a more holistic approach to building performance. So how does this work? Well, in the Analyze tab, you might have noticed from the previous iterations of Revit that you have this entire panel for energy analysis, and I hope that you are somewhat familiar with this, how you set up the settings and so on and so forth. And then last year we saw the addition of heating, cooling, the lighting, and the solar tools available here. This year we have Insight 360, which more or less brings all of that together in the cloud. And what it does is it allows you to generate insight, as you see in this button, and upload your information to the Autodesk servers. So this is accessible from Revit, and it's also accessible from Format, if you will. So you can do an energy analysis directly from Format, and this is an example of something like that from Format. This is pretty much the same kinds of data that you would see from the Green Building Studio tool, except that it's a lot more easier to read, and it's a lot more easier to manipulate, for instance. I mean, you can, it's a lot more, I'd like to think it's a lot more user-friendly. So you can figure out, you know, what your energy consumption is. You can also figure out what your heating and cooling loads are going to be, and so on and so forth. A very interesting, very exciting tool. If you're already doing this, I'm sure a lot of this would make sense to you. If you're not, then you probably have to read up on the different options and what these numbers mean. And of course, to make it easy, you have a whole round number here that tells you, okay, this is what your cost is going to be for a year or so. And this also is designed for non-Revit users, if you will. So you can explode your building if you want. You can look at some of the properties and so on and so forth. Fairly interesting little tool. A lot of potential. We still have to see a larger rate of adoption of these tools in the market right now. So the next feature that we have for 2017 is global parameters. Now, this is a strange enhancement, if you will, simply because it does a lot of great things, that it satisfies a need, but it also straddles between shared parameters and project parameters. So the simplest use case scenario would be something like this. So say we had 4 walls, and let's say if we had two dimensions, we can assign any of these project dimensions to a global parameter. So I can say this needs to be the depth, and this needs to be the width. Okay. All right. So far so good. This is centrally controlled or centrally stored in the projects. So under the Manage tab, you will see global parameters with this. The beauty of this system is that you can now assign the same parameters to multiple objects or multiple rooms or multiple positions or anything in that vein. Now, if I were to try and move this, what you'll notice is that it also serves as a constraint. You can't really move the wall in relation to the other walls. You'll end up moving the entire building. However, global parameters also allow you to create formulas. So let's say the depth needs to be the width divided by 2. This is a slightly tricky proposition because yes, you will get the change, you will see the change, but it still doesn't change the behavior where it still constrains your building. So one of the options you have here is the ability to say that the width of this parameter is a reporting parameter. Now, I'm sure some of you are familiar with reporting parameter. Most of you are familiar with reporting parameters. It's been around for a while. So once you make something a reporting parameter, essentially it becomes somewhat of a read-only proposition here. So now what you have is the building. Sorry, I think I made the width the reporting parameter. So the moment I change the width of this building, the depth changes according to the formula. Now this is a very simplistic formula, but you can extrapolate this to much more complex situations. All right. The next part is about improved software performance. Now Autodesk keeps improving the software, allows the software to use more and more cores. Since we seem to have hit a limit in terms of hardware as to how fast your processor can work, most companies have added more and more processors rather than increasing the speed of the processor. So Revit has been evolving over the years to take advantage of the fact that you have lots of processors rather than one single processor that can go very fast. So yes, as you can see on the slide, there are some changes with how Revit processes color fills, how it displays elements or does not display element, and all in all, it turns out that you can rotate or orbit the view, you can pan the views a lot more quicker. You don't have to say okay to a tool and then wait around for 2-3 minutes for everything to be done. So this is one of those tricky enhancements where you don't really notice this until you start working on large complex projects. So and those of you who worked with say 2013 or 2012 and then maybe started working on a project in 2015 or 2016, I'm sure you would have noticed a significant difference or significant improvement in terms of how the software responds to you, and also in terms of how the software does not crash as often as it used to. So lots of little improvements, but it's mostly under the hood. And I'm sure you might have seen, or there are lots of online resources that compares the speed between the previous version and the current version and the different effects that you may have with the software. So feel free to just go Google it, and you'll be able to find a ton of examples as to how the software has improved over time. Next, we have the Autodesk Ray Tracer. So far, until the 2015 version, Autodesk used NVIDIA's Mental Ray renderer for rendering your views from within Revit. Last year, Autodesk introduced the Autodesk Ray Tracer and gave it as an option, so you could use either Mental Ray or Autodesk Ray Tracer. For the 2017 version, you only have access to the Autodesk Ray Tracer. It is more accurate in terms of the physical rotation of light, materials, and reflected lights, and it's also a lot faster than the Mental Ray. What the trade-off might be, and this is pure speculation, is that what Mental Ray or the Mental Ray algorithms might have done is it would have taken some artistic licenses or freedoms to enhance your rendering, and Ray Tracer will probably give you the space the way it is right now. So now if you want a much more nicer rendering, you probably have to pay a lot more attention to how you set up your lights, how you set up your materials, and so on. But to the naked eye, to someone who doesn't do rendering for a living, you probably won't be able to notice the difference. Now the controversial enhancement It's the text editor. If you haven't heard, if you upgrade from, say, a 2015 or a 2016 project to Revit 2017, you may notice that the right justified text, might spill over outside of the text box and so on and so forth. But in all, this enhancement is geared towards being able to work more seamlessly with the AutoCAD text layout system. So if you were to export any Revit projects to AutoCAD or import any AutoCAD drawings into Revit, the text would not be as fragmented, as distorted as you have experienced so far. So that is the biggest change. Unfortunately, the side effect of that is that certain fonts don't really take to that Autodesk standard or AutoCAD standard very easily, and that's the reason why you may see some adjustments in terms of kerning of the text. Okay, so this editor gives you what you see is what you get, kind of a design. So it lets you set uppercase, lowercase, subscript, superscript. You can add spaces, bullet points, multi-level lists, indenting, incrementing numbers, and so on and so forth. So it has pretty much all the features that you would come to expect in a standard professional text editor. Someone sent me an email earlier asking, hey, can you do stacked dimensions with these text? Stacked dimensions are where possible in AutoCAD, or are possible in AutoCAD using ASCII codes. That functionality is still not available, so you cannot use ASCII codes to create stacked text or stacked fractions. However, the workaround that this individual found was to basically do stacked fractions in Word and copy and paste it into Revit. So that works. You can generally copy and paste anything from Word into Revit. It keeps the bullet points. It keeps the text bold and italics on. It doesn't really transfer over the over the indents and the font. So if you set your Revit font to be Arial and you are copying in Verdana, you're going to get Arial at the end of the day within Revit. So there are a few nuances that probably needs to be ironed out in the future, but as it stands right now, the text editor is fairly good if you're trying to start a new project with 2017. Next, we have tags. Annotation tags can now do calculated values. So let's see if I can bring that up. So let's say I have this particular project, and let's say I have this particular room tag that I would like to modify. So let's say this room object. Where can I get this? Let's see the properties. Let's say this, and this is a made-up number. So those hospital designers out there, please don't judge me. So let's say that the area per occupant for a restroom is 10 square feet per person. So let's say I want to show the occupant load of this room within the tag. It is now possible to do that using a calculated value. So all I need to do is edit the tag family, hide this temporarily, and then edit the label showing the area, and say I want to add one parameter, which is a calculated parameter, and let's say this is the occupant load. And the formula to calculate the occupant load would be area divided by area per occupant. So that would be, oh, okay. So out of the box, you don't have area per occupant in this particular family. So in that scenario, what you would need to do is you would need to basically create a shared parameter that's connected to the project and add that to this tag. So now you can add in the calculated value that gives you area divided by area per occupant. Okay, and you can also do round up and round down to accomplish a round value. So I can say round up, it's a area by area per occupant, and then I can say that needs to show up in the line below, and I can also say, I can even put in a little prefix, so I can say occupant load. All right. So now when I push this into my project, I have this calculated value. Of course, I can change the aesthetics of this a little bit, but I have this calculated value showing up in my tag. So that's a very useful little enhancement that we have in the 2017 version. In addition to that, we also have the ability to pin tags, and when you reposition the element, the pin tag remains in place while the leader can adjust to accommodate the new position of the element. Pin tag does not relocate when the leader is turned on or off, and when it is set to free end. Okay, so additionally, the leader of the pin tag does not change its shape when you switch from free end to attached end. Next, we have an integrated Dynamo tool within Revit 2017. Now, at this point, I'd like you to raise your hands if you have played around with Dynamo. All right, so those of you who have played around with Dynamo, please raise your hands. Okay, so about 20-25. Oh, the number's climbing. Okay, about 17% of the folks have played around with Dynamo. So Dynamo is, as you can see here, is a visual programming language. It works with the idea of nodes within the software, and if you look up the Dynamo forum or the Dynamo BIM website, you'll see a lot of interesting. If I can get this to work. Okay, the images that you, and I'm addressing this to people who don't use Dynamo so much, saying that, hey, we don't do crazy geometry, so why do we need something like this? I'd like to use this opportunity to dispel that myth, if you will, simply because Dynamo is for everybody, or anyone can use this interface to accomplish very mundane things that you may spend more time doing manually or one by one. So now you have the Dynamo tool within the Manage tab. Previously it was in the Add-ins tab. So within the Manage tab, if I click on the tool, it opens up the Dynamo interface. All that is good. And the way this works, and for those of you who are not familiar with this, is that you have a graph on the right, and then you have a bunch of nodes on the left. So if I wanted to, say, create a new level, for instance, I just need to find the level node and say I want to create a level by elevation. And the way, and right now the project has two elevations, say level 1 and level 2. Let's say I wanted to create level 3 at 24 or 30 feet. I can just add the 30-foot number in here and hook it up to my node, and I have have the 30-foot numbers. All right, so this is a very simple, very I guess simplistic explanation of how this tool functions. Of course, you can do complex geometry. Of course, you can do algorithms. You can do all sorts of things. You can do solar analysis, energy analysis, and so on and so forth. But at the very baseline, all you're doing is you're taking parts of the Revit functionality and organizing this in terms of nodes and graphs, and then you have a run button that basically generates all of this, or generates components within Revit. Just to take this demonstration one step ahead, I have a little example of how you could use this for something really useful within your projects. So let's say you would like to keep track of all your elevations, all your levels in an Excel spreadsheet. Okay, so I have this Excel spreadsheet. If I can open it, let's say Dynamo. I can't find that now. All right, so it's over here. It'll open up in a minute. Okay, so essentially what I'm doing here is I am pointing this graph to this Excel spreadsheet and saying it needs to look into sheet 1, and then I have a few nodes that does nice things. But if I were to abstract this whole thing, essentially what it does is it reads from Excel, reads anything that's there in Excel. It takes the existing project levels and matches it to Excel names, and then finally it creates new elevations based on what's in Excel, and then at the end writes back all that information to Excel. So if I run this graph, it opens up the Excel file and then adds in the two levels that were there in this project. So as you can see here, this project has these two levels, level 1 and level 2. It just added in those levels. So let's say I want to rename those levels and change the naming convention to something like this. I want them called ground floor, first floor, and so on. So I can go ahead and change that. I can also say, you know what, I want to create new levels for all of these height values, and so I can go ahead and add those values in there as well. And now when I run the script once again, it will take in those Excel values and create levels for me. Okay, this is okay. It takes a little bit of time to figure this out, but at the end of the day, once you have this set up in your projects, you can use it over multiple projects. I mean, this is an example with levels. So you can do this with rooms, room data sheets, furniture, lighting. I mean, you can name anything within the Revit interface. Anything that has a parameter can be managed or controlled from within Dynamo. The fundamental difference being that you're doing this a whole lot faster from within Dynamo. So before I wrap up, just to show how this works once again, let's say I created a roof level within Revit. This script also can take this roof level and update your Excel spreadsheet from the Revit project. So it's a bi-directional management tool. It reads from Excel. It also reads from Revit and can go back and forth. It's a really simple, or I wouldn't say really simple, but it's somewhat simple. You do need to spend a little time experimenting with this, but it's a really useful little tool to have without having to learn how to code or how to do complicated software integrations. All right. So that was Dynamo. Next, we have what are known as tangency locks. It's fairly easy to understand. The idea is that this method of drawing works in in sketch views. So for example, if I were in a floor sketch and I had created these flits, what you see here is what is known as the tangency lock. And to explain how this works, I'm going to lock just this and leave the other side alone. And let's say this line moved up over here. You see how this angle is maintained. So that's what the tangency lock does. And just to contrast that, this side does not have the tangency lock, so this is what happens. This is really useful if you have rounded corners in your families especially, and these families are parametric. So if you were to stretch or change the shape of your families and you had these rounded corners, you want these rounded corners to maintain their tangency to the straight sides. So you can set up these tangency locks to control that. Again, a minor improvement, but very useful nevertheless. All right. Finally, we have something that's been in the works, or something that's been requested for a very long time as far as schedules are concerned. You can finally set up a schedule template. So the template can include parameters for fields, filters, sorting and grouping setups, formatting, appearance, and even face filters. So I mean, this makes life easy whenever you want to roll a schedule template into your project template and you want to replicate schedules across multiple projects based on your office standards. So this has been a long-standing request and it is finally here. I hope that you don't need a demo for this. It's fairly simple to understand. You're already familiar with the view schedules, and this is just a step. It's just an inclusion into the whole realm of view templates. All right. Next, let's look at enhancements for structural engineers. And although it's labeled as structural engineers, this is for anybody, especially architects who work on projects holistically. You know, the structural engineer formally does not necessarily come in at the beginning of the project, but you still have to visualize structure, especially if you have exposed structure. How would you detail those structures? How do you show the little angles and brackets and nuts and bolts that you need for the visualization? The 2017 version has a lot of improvements that incorporates detailing tools for both structural engineers and architects. All right. Firstly, we'll look at reinforcement connectors. Again, you know, sometimes you see structural engineers getting into shop drawings or detailing, or you could be an independent detailing outfit. The idea here is that you can do a lot with reinforcement, rebars, and fabric reinforcement. So reinforcement connectors are family-based and are fully customizable, and they can interact with the rebar that they connect to. So if the rebar changes position, these connectors will update automatically. You can use schematic connectors to define requirements. Detailers can use them to produce shop drawings. Manufacturers can go into full detail, precisely modeling and representing reinforcement connectors. And also you can create installation instructions with these. Okay, you can add connectors to groups, assemblies, and petitions, and also they have unique coupler numbering and annotation formats that you can use to either illustrate your design or you export to other formats. So we can do a little demonstration of this. So let's say fabric sheet, reinforcement connectors. So let's say we have two reinforced concrete columns, and let's say these columns or these rebars are not exactly joined. So within the structure tab, you now have a new tool called the Rebar Coupler that essentially lets you pick two sets of reinforcements and fills in the coupler between the reinforcements. Again, a fairly innocuous looking tool, but it shows you everything with complete detail down to the nuts and bolts, and it's very good for illustrating or for instructions or for installation instructions. Sorry. Next, we have the ability to show rebar distribution across a variable section. Okay, so you can so far if you had reinforcement and if you could only work with a rectangular section or a fixed cross section. Now it's possible to work with a variable cross section. Again, it's just a little tool. It's a very innocuous looking tool, but then it could make a huge difference for people working with these kinds of projects. So the tool in question is this particular tool that you see here, bearing rebar set. If I disable it, you will see how the rebar goes across as a rectangular section, and once you enable it, the rebar can be changed. So I can also change the number of rebar and so on and so forth. So that's pretty much what that is. We also have something called the graphical rebar constraints. Okay, you can experience an improved reinforcement workflow because these constraints are now in Canvas tools, and they replace an extra step, an extra dialog box. And what this allows you to do is it allows you to place rebar more precisely, and you can place standard rebar shapes that snap to adjacent standard rebar, or constrain them to host faces. The way this works is, let's see if I can get this file open. Okay. Okay, so this is a footing, and let's say I want to edit the position of this rebar. So the moment I select this rebar, I have in my contextual tab the edit constraints option, and that gets me into a sketch mode with temporary dimensions that lets me position the rebar very precisely. Also, it lets me change the length of the rebar if I want, and so on and so forth. And this is a very accurate way of doing this. And one of the nice things about the way constraints work is that even if your footing sizes were to change, your rebar constraints, because they are associated to the face of the surrounding concrete, they will update automatically as well. So a really useful tool as far as structural detailing is concerned. You also have the place fabric reinforcement sheets, and these can be bent sheets, as you can see from the image on the right, top right rather. The bent sheets can be created because by changing the profile of the concrete, and you can edit them, you can do whatever you need to do with them using this particular tool. This is the most exciting part, as far as, I mean, for me at the very least. You have the ability to add structural connections that are more than generic angular connections, okay, or symbolic connections. So especially if you have exposed structure, you would like to see the brackets, you'd like to see the face plates and so on and so forth within your projects, and now that is possible with the 2017 version. You can also add annotations for each of these connections so that it's easier for the detailer or the fabricator to catalog these connections and cost them and whatnot. So this is fairly easy to demonstrate, so I'm going to go ahead and show this to you. So let's say I have two columns like so, and then I have a beam connecting these two columns. All right, so this is what it looks like in 3D, and I'm gonna make this a hidden line, and I'm also gonna make this fine, because the connectors are not visible in the I mean, they're visible as generic symbols in the medium and the coarse level of detail. All right, so the connection tools are available with this new button that's available in the Structure tab. And one of the things you will need to do if you want something more than a generic connection is to go into the structural connection settings here and say, I want the following connection. So in this case, I want the knee of the frame bolted with hunch, and let's say for the next step, I'd like to have a front plate splice as well. All right, so I need to load this into my project through my structural connection settings, and once I've done that, I can select the connection tool, hold my control down, select the two pieces that need to be connected, and the default is the generic connection, and which is what you have in 2016. But you can now switch over to one of these connections that you've created or that you've loaded into the project. Sorry, I think I lost that. And then if you hit enter, you'll end up with that connection being shown here. Okay, it's a fairly easy way to get detailed models, and structural engineers can use this for calculations or detailed drawings, but architects, I can imagine architects using these for showing renderings and so on, how these elements, how the building goes together. So it's also possible to modify parameters attached to these connections. All right, so it's wait, sorry, did I miss that? Yes, I did. I would have to hit the enter for this to update, and it's fairly easy to work with at the end of the day. Similar to that, you can now split vertical columns within Revit structure. So if you had one single column going from the ground floor all the way up to the roof, you can split them at each level, and also you can add these connectors to join the splits. So the way the split works is by using the generic split tool that you may be already familiar with this, and just split it like so. So now you have two columns, and then you can go ahead and use the connector with the front plate splice to add the additional piece in there. So as you can see, it came up with a plate splice. There have been a few improvements as far as steel profile catalogs go. You now have steel profile catalogs for Australia, New Zealand, Germany, France, Poland, US, India, and they're all based on the Eurocode. So at the end of the day, you're seeing the inclusion of a lot more content. And for those of you who do work on international projects, this is a fantastic addition, right? Last but not the least, you can now attach structural columns to isolated footings and foundations. The byproduct of that is that if the footing were to go lower or change in size, the column would still remain attached to it. And this just makes life easier for people working with these systems. They don't have to manually go and join things or upgrade things.